Okay, guys, I'm going to help you out with lesson 27's homework. Last one for the week. Woohoo! All right, and let's go ahead and get started. I crossed out some that my class isn't going to be doing. You can ask your teacher if she still wants you to do them. But let's start off with number 1. It says draw a tape diagram to model each comparison using greater than, less than, or equal to. So I'm going to compare 2 3/4 to 2 7/8. Well, they both have 2 holes. So we really don't, we can draw them out. I'm going to do it on this first one, but when they have the same holes, you only really have to compare their fractions. But I'm going to draw out the whole thing just for fun on this first one. So first in red, I'm going to model 2 3/4. And in blue, I'm modeling, there's 2 holes, and then I'm going to model 7/8. So I'm going to make the rectangle the same size, try to make them as proportional as possible. So now that's split into eighths. And when I fill in 7, 2, 3, 4, 5, 6, 7, it's just a tiny bit bigger than 2 3/4. So I'm going to say 2 7/8 is bigger than 2 3/4. You also know that because 2 7/8 is 1/8 away from being 3. And 2 3/4 is 1/4 away from being 3, so it's farther away. On B, I'm not going to draw all 10 rectangles on both of these. I'm only going to compare the fractions because they're both 10. So I'm going to compare 2 6 in red. One, 2. And then I'm going to compare it to 1/3. Now when I do this, they're going to look about equal, and it's almost too close to tell. And so I think they look equal, but let's see. Let's check it out. Let's say 2 6. If it were equal to 1/3, I should be able to divide the top and the bottom by the same number. Well, 6 divided by 2 is 3, and 2 divided by 2 is 1, so it checks out, and these two are equal because 2 6 is equal to 1/3. Okay, let's check out C. Again, the whole numbers are the same, so I'm only going to compare the fractions. I'm going to compare 3/8 to 1/4. I'm going to draw 3/8 in red. So first I got to separate into eighths, that's fourths. I'm actually going to split both of them in fourths underneath each other so I can tell they're as equal as possible. And now let's split the top into eighths so I can color in 3/8. 1, 2, 3. And then I'm only going to color in a fourth down here in blue. Now it looks like it's bigger because it is, and also because 2/8 is the same thing as 1/4, so 3/8 is going to be larger than 1/4. Okay, we're skipping number 2 because neither one of those fractions are ones we should deal with, and we're going to go down to number 3. And you can compare them using any strategy, so I'm going to use a variety of different ones, just whatever suits the situation best. So on A, it says 6 1/2 and 6 3/8. The wholes are the same, so I'm just comparing the fractions. Well, 1/2 and 3/8. 3/8 is a little bit less than 1/2 because 1/2 and 8 would be 4/8. And so that means 3/8 is less than 4/8, which makes 3/8 less than 1/2. So 6 1/2 is greater than 6 3/8. Okay, on B, we have 7 5/6 and 7 11/12. Well, the whole numbers are the same, and they are both 1 away from being a whole. However, 7 5/6 is a whole 6 away from being a whole, and 7 11/12 is a whole 12th away, or is a smaller 12th away from being a whole. Because see, if I added a 6 here, I'd get a whole. If I added a 12th here, I would get a whole. But adding a 12th is a lot smaller than adding a 6, so that makes 11/12 larger than the 5/6. So 7 5/6 is less than 7 11/12. Also, you could also do it this way. You could say 5/6 is equal to how many 12ths? Well, 6 times 2 is 12, so 5 times 2 would give you 10, and 10/12 is going to be less than 11/12. So you could have changed 6 to 12 to compare them easier that way. Okay, on E, we're lucky because the numerators are the same, and when that happens, you just compare the bottoms. Well, a third is always going to be bigger than a fourth, so 10/3 is going to be greater than 10/4, even though that seems the opposite. A third is always, well, my rectangles aren't great. Let me fix the bottom one. If I cut a cake into thirds and cut a cake into fourths, the one that's cut into thirds, the pieces are going to be a little bit bigger. So my third is going to be bigger than my fourth, so 10 thirds is bigger than 10 fourths. All right, on part F, we have 12 fourths and 10 thirds. That's a little bit difficult to compare like they are because the numerators aren't the same, the denominators aren't the same. And so I'm going to change these into mixed numbers. Well, 12 fourths is going to be the same thing as 3. And 10 thirds, well, if I counted 3 thirds would be 1 whole, 6 thirds would be 2 wholes, sorry. 9 thirds would be 3 wholes, and that's even more, so let's see. 9 thirds would be 3 wholes. Here, so 3 thirds is 1, 6 thirds is 2, 9 thirds is 3, and then, so I'd have 3 and a 1/3 left over, so it's just a tiny bit bigger, so this one's going to be larger. Okay, we're probably going to have to do the same thing on H because one of them is a fraction greater than 1 and one of them is a mixed number, so I'm going to turn 23 fourths into a mixed number. Again, I'm going to count by, well, 4 fourths is a whole, 8 fourths would be 2 wholes, 12 fourths would be 3 wholes, 16 fourths would be 4 wholes, 20 fourths would be 5 wholes, and 24 fourths would be 6 wholes, but we only have 23 fourths, so we're going to go with the 20 fourths, which is the same thing as 5. And that leaves us with 3 fourths left over. So now we're comparing 5 and 3 fourths to 5 and 2 thirds. Well, 3 fourths is a fourth away from being a whole, and 2 thirds is a third away, and a fourth away is closer than a third away. So 5 and 3 fourths is going to be larger than 5 and 2 thirds. Okay, next one we have 28ths. So we're going to change this one to a mixed number 2. So 8/8 is a whole, 16/8 would be 2 wholes, and 24/8 would be 3. So we're stuck somewhere. Excuse me, that's 30/8. So the closest I can get would be 24/8, which would be 3 wholes. And since it's 30, there's going to be 6 left over. So that's 3 and 6/8. And the other one is 3 and 7/12. So that's still kind of hard to compare. They have the same whole number, but we're trying to compare 6/8 and 7/12. And there's not a really good benchmark fraction to really help you out here. So, well, 7/12 is 1/12 bigger than a half. And 6/8 is 2/8 bigger than a half, so 2/8 is going to be a little bit bigger than 1/12 bigger than a half, so that's going to make 3 and 6/8 larger than 3 and 7/12. Okay, let's look at J. We have 10 and 3 fourths, and we're comparing it to 10 and 1/6. So we're going to compare this, 4/6. So 3 fourths and 4/6 are really difficult to compare. They're just too close for comfort to make the call. So I'm going to do something we learned in this lesson, and we're going to find a common denominator that they can both go into. Well, I know 4 and 6 both go easily into 12, so I'm going to turn them both into 12ths. Well, 3 fourths is the same thing as 9/12 because 4 times 3 would give you 12, and we got to do the same to the numerator, and we'll get 9/12. Well, here 6 times 2 gives you 12, so we have to multiply the numerator by 2, and we get 8/12. So you see that why they were so hard to compare is they were barely, one was bigger than the other by only 1/12. So that makes 10 and 3 fourths 1/12 bigger than 10 and 4/6. Thanks, guys.